Hey class, in today's lesson we're going to talk about trigonometric functions of any angle, which is found in section 4.4 part 1. Our objectives are to elevate trigonometric functions of any angle, to use reference angles to evaluate trigonometric functions. So in example 1 it says, let -3, 4 be a point on the terminal side of theta. Find sine, cosine, and tangent of theta. So as a reminder, when we are talking about theta, we're just wanting it to represent some angle, right? So sine, cosine, and theta of some angle. All right, so if you think about an ordered pair, -3, 4, where or what quadrant would it fall in? Technically, -3, 4 would fall in quadrant 2. Okay, so if I were to set that up, 3, 4 would be in that quadrant. Okay, so think about it. When we want to evaluate and you've been given an ordered pair, what you typically want to do is you want to create where in space that would be. So in other words, we have to make a triangle in each quadrant. So -3 is on the x-axis. So if I created a triangle, right, -3 is actually technically +3 in length, and 4 is your vertical distance, right? So technically 4 is right there, so just make it parallel to the vertical line of your triangle, and so we have 3 and 4. So if you have those two sides and they're asking you to find sine, cosine, and tangent, it'd probably be in our best interest to go ahead and find the hypotenuse of that triangle. So as a reminder, we have a squared plus b squared equal to c squared. So that would be 3 squared plus 4 squared equal to c squared. That would be 9 plus 16 equal to c squared, which would make this 25 equal to c squared. If we take the square root, c will equal 5. So our missing length for our triangle, the hypotenuse, is 5. All right, so going back to the original question, what is sine theta, cosine theta, and tangent theta? Well, sine theta, as a reminder, is technically the x value of, sine theta is opposite over hypotenuse, right? SOHCAHTOA, so opposite over hypotenuse. So if we're talking about opposite over hypotenuse, the opposite side of your theta is 4, and your hypotenuse then is 5. Cosine theta will be adjacent over hypotenuse. The adjacent side is 3, the hypotenuse is 5. Remember, adjacent means next to. And then tangent theta is opposite over adjacent. So opposite, in our case, will be 4, and adjacent will be 3. Okay, so there are the 3 trig functions if you're given an ordered pair, a point. This chart just kind of lets you know what's considered positive in certain quadrants, what's considered negative in certain quadrants. We've already done this before when we first learned the unit circle. So this is just something to look at. All right, so let's continue to practice, and this is more so from what we had on the other one. And I want to rewrite this a little bit because I didn't have certain symbols in my bank when I was trying to write this out. So if I see tangent theta equals -5/4, that's really supposed to be tan theta equals -5/4. That's actually how you would see it. And then it says, and then cosine theta is greater than 0. Find sine theta and cosine or secant theta. All right, so I just wanted you to be able to see it in the way that you would actually see it in a textbook. Okay, so a few facts that were given to you so that you could figure out, because this really just comes down to what quadrant should I place my triangle in, right? Okay, so they're saying that cosine theta must be positive. Remember, cosine is actually your x value, so where is cosine positive? That means where's your x values positive if you think about out of your 4 quadrants. So technically, cosine is only positive in quadrant 1 and in quadrant 4. And then tangent theta is negative out of 1 and 4. Tangent is only negative in quadrant 4. So out of 1 and 4, tangent is negative out of 1 and 4 because technically tangent is only negative in quadrants 2 and 4. So since 4 is the overlap, then that means our triangle really needs to be set up in quadrant 4. Okay, theta is always your central angle. Okay, so if they tell you that tangent is negative 5/4, if tangent theta is negative 5/4, then you need to remember what tangent is, and tangent is opposite over adjacent. So the opposite side of theta is 5, and the adjacent side of theta is 4. Now, this is not a 3, 4, 5 triangle, because if it were a 3, 4, 5, meaning a Pythagorean triple, it would only be that case if 3 and 4 were the side lengths or the leg lengths and the hypotenuse were 5. But in this case, 5 is already a leg length, so we actually need to go through and do that entire process. So a squared plus b squared equals c squared. A is 4, b is 5. So 4 is 16, 5 is 25, equal to c squared. 16 and 25 is 41. So that means that c will be equal to the square root of 41. So the square root of 41 is our c value. Okay, from there, all we need to do is answer what is sine and what is secant. So sine theta, remember, is opposite over hypotenuse. Okay, so the opposite length is 5, and the hypotenuse is the square root of 41. However, we never leave radicals in the denominator, so we need to rationalize it by multiplying by the square root of 41. That gives us an answer of 5 square root of 41 over 41. All right, secant theta, then, remember, is the reciprocal of cosine, which would be 1 over cosine theta. As a reminder, cosine is adjacent over hypotenuse. So if it's the reciprocal of that, then we're really looking for hypotenuse over adjacent. Our hypotenuse is the square root of 41, and the adjacent side length is 4. So square root of 41 over 4 is secant theta. So in example 3, it says to evaluate the sine and cosine functions at the 4 quadrant angles below. So it says 4 quadrant angles. I typically say that these are the ones that fall on the axis. And so I'm going to rewrite our axis and what those ordered pairs are. So that'd be a little bit easier for us to answer. Okay, the positive x-axis, remember, is 1, 0. Therefore, the negative x-axis would be negative 1, 0. The positive y-axis is 0, 1. Therefore, the negative y-axis is 0, negative 1. All right. As a reminder, your sine values are they are your y values, and cosine is your x. So if I try to find cosine of 0, I don't know why I put a parentheses, but cosine of 0, cosine of 0, which is this ordered pair here, cosine of 0 is 1, and sine of 0 is 0. Okay? Moving around the axes. Next, we would have cosine of pi over 2 and sine of pi over 2. Okay, cosine of pi over 2 is 0 because that's the x value, and sine of pi over 2 would be 1. Again, continuing to move about the axis. Then cosine of pi, as a reminder, pi is over here. So cosine of pi would be negative 1, and sine of pi would be 0. And then lastly, cosine of 3 pi over 2 would be 0, and sine of 3 pi over 2 would be negative 1. And there you have it. Okay, this just talks to us about reference angles. So it says the values of the trigonometric functions of angles greater than 90 degrees or less than 0 degrees can be determined from their values at corresponding acute angles called reference angles. So in other words, we say that reference angles are the amount of degrees just a little bit before or a little bit after the x-axis, right? In other words, when we try to, and we use this because when we try to create our triangles that go within our quadrants to be able to answer the sine, cosine, tangent, and the other trig functions, it helps us to know what some of the more popular ones are for the unit circle. And yeah, so that's pretty much it. Okay, so for example 4, finding the reference angle. So to find the reference angle for 300 degrees and then to find the reference angle for 2.3. As a reminder, 300 degrees, if this is 180 degrees and this is 270, 300 is in this quadrant here. Let's just say it's here, okay? However, to find the reference angle means what is this length here, and I'll call that theta. What is this length here that will get me back to the x-axis, right? Because when we talk about reference angles, we care mostly about the x-axis. Okay, so how many more degrees would it take me to get to where I need to be? So the reference angle then would be 60 degrees, right? Because the entire circle or unit circle would have 360 degrees. So if I've gone 300, you need another 60 more to get back to 360. And mathematically, if you want to know how to find that, then we would say 360 degrees minus 300 equals 60 degrees. And again, I knew I was going to use 360 because it was already past 180, right? So if it's before 180, then you would say 180 minus whatever. But in this case, we're not. Okay, on the next one, 2.3. If you remember, this is already in radians. So if this is 2.3 radians, think about pi, right? Pi is technically 3.14 radians, right? So if we're trying to go to 2.8, right? 2.3. 2.3 is probably somewhere over here. And I know that it's past the pi over 2, because pi over 2 would be half of 3.14, which is about 1 point something, but I know it's greater than 2.8. All right, so to figure out the additional length needed, right, to get back to an x-axis, I'm going to do pi minus 2.3 to figure out that reference angle, or 3.14 minus, and really I shouldn't use 3.14, we should really use pi, so let me leave it as is. Pi minus 2.3, and that's going to give us about 0.84. So 0.84 is the reference angle, just as 60 degrees was the reference angle in our last problem. And then the last one for our try, it asks for us to find the reference angle for negative 135 degrees. So let's think about it. Negative 135 degrees then means if it's negative, it goes backwards, right? So this would have been negative 90. And going completely to the x-axis would have been negative 180. So negative 135, I'm going to say is right about here somewhere, okay? So again, we're trying to get to an x-axis. So we ask, how much do we need to get back to the x-axis? So if this represents negative 180, then we need to ask ourselves, what's the difference? So how much more does negative 135 need to get to negative 180? And the difference is 45. It's an additional 45 degrees. And mathematically, I just like to deal in positive, so I would have said 180 degrees minus 135 degrees gave me 45 degrees. So 45 is the reference angle. All right, guys, if you have any questions about this, please be sure to come see me for tutoring.